Okay, so today we are going to discuss about the I/O system. I don't think it takes a long time. It will be finished soon. And on May 2nd, we will have the final exam. So final exam time is at 10:45 to the 12:45, but I'm thinking the 1.5 hour. Okay, so it may be finished earlier. The exam format is the same as the last time, so please bring your laptop. Before you come, please take the practice test. Practice test is still available, so you can test, but I'm going to upload one more time. So to test the lockdown browser. So last time during the midterm exam, couple of students couldn't finish the midterm exam. So, but this time I'm not going to give any excuse. So please be ready before you come to here to check your network connection. So it doesn't require the very strong wide bandwidth of the network. So if you want to, you can use the tethering through the data plan. So because sometimes if all students connect to the Wi-Fi, sometimes it's a little bit slower. And do not download the lockdown browser after you come to the class. Please install before you come to here. And also when you start the lockdown browser, so first try to start the lockdown browser through the Canvas. Okay. So if you already installed, then everything is good. So you can start from by clicking the quiz on the Canvas. Then it will start up your lockdown browser. Then if that doesn't work, then go to the lockdown browser and do it. So lockdown browser, once you start the lockdown browser, you cannot do any other thing. So the only way is you need to restart your system. But if you forcefully log out, terminate over to the system, you are able to log in again, resume your test. So regarding to the exam format, less than half of them, I think around half of them will be the midterm, the multiple choices. Half of the multiple choices question from the quiz that we have done after the midterm exam. I think that this time the exam will cover the chapter 7 through the chapter 13. So please don't forget. Some of the students forget about the chapter 7. Chapter 7 is also part of the final exam, even though that is a part of the process management. Okay. So then after we finish the final exam, you will check the grade of the final exam, just like the midterm exam. I'm thinking to offer the office hour when you can check the final exam only. Okay. So please contact GA, the Umang or me, if you have any problem on your grading except the final exam, before final exam. Okay. So I'm not going to take care of any appeal or the complaint after the final exam regarding to your grade. If you have any issue or any problem, or check the Canvas, okay? Whether the project or the homework are graded. If there is any problem, please contact the GA or me before final exam. After the final exam, you are able to check only final exam sheet through the online. Then your final grade will be posted probably same time as the same date. The same date of the final exam, that will be May 2nd, or once GA complete all your grading, because some of the students may delay to demonstrate. So, but as soon as I receive all the grade of the project 2, then I will finalize the final grade. So regarding to the final grade, some of the students pay attention to the percentile or bunch of number which I don't create, the Canvas create, such as the percentile weighted number or whatever. That's not the intention. There's no way to remove or invalidate such the percentile or weighted number, ignore such a number, because such a number do not consider the weight. So I'm going to consider our own grading policy that is slightly introduced at the beginning of semester, but I probably mentioned do not pay attention too much. Based on your overall performance, it may be different, but overall, the midterm and final exam will be 40 around the 45%. Sometimes it can be 40%, sometimes it can be 50%, but around the 45% of them. And the other 40% usually is a project. So you had 3 projects, the project 0, 1, 2. So undergraduate student did the project 0 and 1, but the 2 will be extra point. And then the 10 to 15% will be quiz, attendance, and scheduled homework. Okay, so this will be, if there's any the other activity in the classroom, that will be part of it. This is rough, but I will definitely let you know the detail, the grading policy, how I can calculate the weighted total. Then based on the weighted total, also I usually apply the curve to the weighted total, not for each the individual. For the weighted total, I usually focus on the 75 to 80 as the B range. Okay, so then you can imagine the usually A or the A minus is upper 80. Okay, depending on the overall performance, it's different, but usually. But I usually, if that is your overall performance weighted total is less than the usual, comparing to the semester, then I apply the curve. So, but otherwise, when I apply the curve, I'm not adding the number. Instead, I lower the grading range. Okay, it's the same thing, but I usually lower the grading range. So then the B level is usually I focus on the upper 70, 75 to the 80, lower 80. That will be the B range. Okay. Then any question regarding to the exam, final grade? Then you may see your final grade probably middle of the next week. Okay. So then please contact the GA or me if you have any doubt or problem on your grade. Except the final exam, the grade. Then after the final exam, I will take care only the final exam, the issues, and the final grade. Okay, so today, also I'd like to finish today's lecture a little bit earlier because I have another activity, which is the mini workshop, the poster session of the NoSQL database. So if you are interested, you can come by. But anyway, before the 12, I will finish the class. Maybe the 45, the 50. So today's topic we already discussed a lot, so we can quickly review and finalize it. Before we start today's lecture, so let me quickly summarize what we have learned so far. So we are talking about the operating system. I have been teaching not all last 11 years, but sometimes I taught and the stop. And the last 3-4 years, I have taught the operating system. Some of the students complain, do I need to learn the operating system because I'm not interested, or I never seen my friend who got a job in the operating system company, something like that. Really. So then there's nothing I can answer. So as you have seen, this is the most frequently asked question. I'd like to be this kind of thing, like the database administrator. Nowadays, many of the students ask, how can I prepare for the data scientist or the data analyst, something like that. But it was the data administrator or something. Any kind of thing, any job or any software engineer or the developer, whatever. So whenever I was asked such a question, my answer is quite similar. You need to study core course of the computer science subject. So core course we have most of them are computer science, computer engineering slightly different. Computer science, we have the program language class. So right now with object-oriented programming, it's a C++, right? So that we have the operating system, database, network, and the algorithm. So these are the basic fundamental courses. So I strongly suggest you better keep the textbook of this class on your bookshelf, even though you don't read. But in my case, I'm the person who don't like reading the bunch of the textbook thickness. Instead, getting familiar with reading PDF or web page more and more. But still, I keep such a paper-based textbook on my bookshelf. So I have our I learned the same textbook. There is it's a current version is a 9th edition. It's still use the similar the book cover, but this was the 5th edition when I learned took the operating system class. It has been edited, but still from time to time I look up some of the topic in the operating system textbook, database textbook, because it's a kind of the fundamental. Even though you do not use directly such an algorithm or a module or such a thing, but as I mentioned many times when I'm teaching database, I probably mention about the operating system. When I'm teaching the big data, I'm mention about the relational database concept and so on. They are the fundamental. It's not only for the operating system itself, it can be used for the many of the applications. So please pay attention. I know some of the students are very interested in the new topic or the new trend of the subject. But I still believe for example, in my case, I learned the first program language with the COBOL. Anyone who are using the COBOL? So still there are job, the requirement, who knows the COBOL. But anyway, but if you understand the basic, the algorithm of how the program language is organized and structured and how they are running, no matter what types of the program language you use, you don't have to worry about too much. The only difference is interface or API or something, the syntax. That's it. You can catch up easily, no matter what kind of the program language you use. Anyway, behind it will be instruction level, the assembly language, and it will be executed by the CPU. So please keep such the core part of the computer system that may be easier for you to get a job and to survive in the IT and the computer science. So nowadays you probably heard about a lot of things like the AI, artificial intelligence, machine learning, and data mining, or big data. So you don't know how to start to catch up such a thing. Do I need to take all the classes? Yeah, if you can do that, so you can do. But I don't suggest to take the learn study each and every class. But if you keep the fundamental, fundamental thing, core part of such a thing. So for example, the big data system definitely based on the operating system and some data structure architecture. So you don't have to learn, even for the big data system, there are a bunch of different the big data system, not only just the Hadoop, but the Hortonworks and some other. And nowadays it's cloud-based. The Google provide their own big data system. The Amazon and the Azure provide their own. So do I need to study each and everything? No, you cannot do that. However, if you keep the fundamental knowledge of such a computer architecture, computer system, operating system, then it's very easy to catch up. Okay. One more thing is in terms of operating system, as I mentioned throughout the semester, please keep the experience on the Linux or Unix-based operating system. It's in terms of the architecture, as you have seen throughout the semester, the Linux and the Unix-based the kernel and their interface operating system are the more close to the academic and the algorithm. The Windows nowadays is a little bit getting back and to expand their customer range, but still I think many of such a new technology starting from the Linux, because many of them are open source project. So, and also open source is another important thing you need to keep in mind. And also this is one of the suggestions and by many of my friend and colleague who work for the company and also the school. The student, when you submit your resume to get a job, so please focusing on expose your experience. Like I heard that nowadays the HR department, they'd like to see the geek up, the activity. Like whether you have so if you did, I know, they know, everybody know the entry-level position, you don't have any experience. So they cannot consider your working position at the specific company. That's not an entry level, so you're already there. So entry level they know, but they'd like to see most of the HR or the manager. They'd like to hire the person who have the experience. How can you expose? So one of them is like the geek up. Like you can use the social media site, or the stackflow.com, you can frequently ask and the question, or not only just downloading bunch of the code, but you can expose your classroom project, or you can little bit decorate and make the interface, then using your own website, or you can use the GitHub also. So please use such a thing to expose your experience, even academic experience. If you did such a thing, then it will be much better. Okay, so my suggestion for that, please be familiar with the command line, the Windows, not only Windows but Unix-based the interface also. So we have talked about what is operating system, such an interface and so on at the beginning of semester. Then the operating system consists of the three main parts of the component. One is process management, and second is the memory management. Third part is the I/O management. So I don't have to mention again and again importance of the process. So surprisingly, even though the master degree, the student, sometimes they do not know how the computer is working. Okay, at least you should be able to explain when you double click or when you run your command, you should be able to explain for 2 hours how your the programming is working to your friend or to your student. Okay, think about whether you can explain such a process or such a functionality when you execute the program inside the computer system. If you can explain such a thing for 2 hours, then that's pretty much enough. So to do that, the process management process is also data structure. It's nothing different. It's just a data structure on the memory. Then since we have always a limited resource, so always we need to think about something synchronization issue or something maximizing the utilization and the performance. So always we need to consider whenever we discuss about the algorithm, how to maximize the utilization, how to increase the performance, and so on. So in the process management, we mostly talk about such a thing. Then the next, even though we are ready to use the computer resources through the process data structure process by creating process, we don't discuss a lot the behind of such operating system like the computing architecture. Definitely, obviously, the computing, especially microprocessor, the CPU, how the CPU is working, assembly languages. So if you probably learn in your undergraduate and in your prerequisite class or the other basic class, computing architecture, please remind from time to time that it's not changed a lot actually. So such a computing architecture is still the last 10 years, last 20 years, so pretty much similar and the same. And the next, I think it will be, unless we have the new chip, like the quantum computing or biochip. Like the biochip may be different. This is based on the silicon, okay? So we have the full, or we can send the signal, but like the NPM, PNP, I'm not very good at such a thing, the chip, and integrate the ICs, so on. But it will be if that is the move to the biochip, like the cell and it's a neuron, using the neuron, it will be totally different. Also, the evidence of the changing computing architecture is quantum computing. So we have such a class. But unless that is popular, I don't think that will be near future, like the 1-2 years, but it will take. That means that we will have the similar computing architecture. Difference is that we have the faster and better and performance of the chip or the bus, and the hardware is like using the Amdahl slope, even though it's more than Amdahl slope, it's 18 months, it will be much higher the performance. Okay, but that means we need to maximize such a resource. So one of them is memory. So we are using the memory, so that is the faster, and we can access through the address, but it's still limited. So to address reduce such a fragmentation, maximize the utilization of the memory resource, we talk about the paging, basically paging. So we consider the process as the virtual memory, and the memory itself is a physical the frame. Then the problem is how to map such a virtual memory to the physical memory by page. That is the main topic of the memory management. Then, so we have the CPU, the process, and we have memory. Then the others are considered as the I/O devices. It is true. Any type of the device or the peripheral, anything is the I/O. One of the I/O devices. Like the screen is the output device, and the keyboard is the input device. The hard disk drive is the input and output device. USB is the bus, it's not actually device. So most of them are I/O device. Then we have the bus to transfer such a data input-output operation. Okay, then we have the controller to manage such a hardware between the hardware device and the operating system. So these are the overall things. So the few classes, so we talk about how to manage the data in the storage device. So we started from the SSD, solid state disk, and hard disk drive, and that is a hardware. On top of that, we need the software, which is a file system too. So file system is the software that has a bunch of the data structure to keep our information. So in the file system, there are two main, the data structure file and directory structure. So if you are using any type of operating system, it's the same thing. So Windows provide the NTFS or the FAT32, so on such a file system. The Linux provide the ext something number, okay, the extended file system, or the UFS and the NFS, like the GFS, the universal file system. So these are the data structure software that manage number of file, number of directory. Then finally, in this chapter, we will see some of the topic we already see how the I/O operation is working in your system in terms of operating system. So today we are going to see the I/O devices, hardware, that pretty much we already discussed, and what is the application interface to use such I/O hardware. For example, we have learned about the interface I/O. And the memory mapped I/O. Those are the interfaces we will summarize such a thing. And also the operating system provides the kernel I/O server system, which is the fundamental of the other I/O system. Okay. So these are the common concept of the I/O device. We have the port. This is a port. Which port? Oh yes, that is so actually from the port. Port is actually where you can dock your chip and connect. Same thing. In the computer system, whether think about the network, TCP/IP. When you make the connection using the TCP/IP, you need to know IP address. Okay, and port number. Port number is kind of a door to access. It's a specified. So it's the same thing. Port. Whenever you connect any type of the I/O device, it should have the port. Then it is connected to it's kind of a highway. Okay, the bridge port is connected to the I-95. Then you can transfer and the trailer and so on. Okay, then. Somebody needs to understand operating system cannot understand each and every device. Instead, operating system, as we discussed last time, the file system layer of the file system, logical layer, and so on, and it has the computer system has the controller. Any I/O device should be connected to the controller. Controller knows how for each. So this device, I/O device, has a different data structure as the other one. But the operating system does not understand each and every variety of the data structure. Instead, this one should be connected to the controller. Then operating system should be able to communicate using the controller. Controller is kind of it's a small, tiny embedded computer. Okay, it has its own instructions sometimes. Okay, the main job is understand the computer signal, then the control that I/O device and return back to the operating system. So because of that, each controller has its own program, okay, which is called the device program. So that is a reason long time ago that we need to install the device program whenever you purchase the new device. However, nowadays you don't have to because it's automatically download, and or sometimes many of them are standardized. For example, one of the examples is the USB. USB is one of the controller, device controller. Okay. So this is one of the example of the such the slot. You can see the PCI Express. So it was nowadays you cannot see the ISA, which was used for the hard disk drive, but nowadays it's either PCI or the PCI slot. So you can this is kind of port. So you can connect if you have any other device, you can connect it to here, or the group of the such a device is set up with the motherboard. So this is a motherboard. Okay. So this is the overview of the such architecture. We have this is the PCI bus. Each PCI bus is connected to the I/O devices through the controller. You can see for example, hard disk drive has the disk controller. The monitor has a graphic controller, and even processor. In terms of the I/O console, is also I/O device has the bridge and the memory controller that can be connected to the memory and the processor. SCSI is another storage controller. So SCSI bus has mostly the 16 devices can be connected. One of them used for the controller, which means 15 devices. And also we have the expansion bus is slower. Most the slower the I/O device like the parallel serial keyboard are connected to the separate, because otherwise if you use this one there is a latency, so we'd better separate such a lower speed the I/O device separately using the expansion bus. So these are the faster device. So this is the computer bus structure. Okay, then each device has as I said, it's like the small embedded computer. So if you go back to your microprocessor class, so in your microprocessor class you learned about it's using what is x86, the 16-bit microprocessor x86, and how it can communicate with the memory. Okay, in the memory, so at the time for example, one of the typical, very popular project of the microprocessor is the printer. Whether you can control the printer from using the assembly language. At the time, you can get the data in register, data out register, whether this one is used one, status register. So first you can check the status register of the controller. Okay, if it's not in use, then you can send the data. Then if that is input and output device also, then output data will be data out register, then communicate with your operating system. Then if you are implementing the device program, it will be done by the device program. So these are the basic. The register included in the device, the controller. Okay. Then each device has mapped to the memory, so which means when each device register data out, the register has the data where the data is going through the bus. It will go to somewhere in your memory, but not randomly. Then if you store everywhere, the CPU would like to check. The operating system need to know where is the data. Instead, why don't we designate the specific area, I/O address in the memory. Then in case of the signal of for example, from the data from the parallel port, just go to this memory address, then get the data. Okay, this is the I/O port is Okay. So then problem is how do we know whether there is the output of the data from I/O devices? So polling is just the sequence of the step, but it's just a check whether bit status register bit is the 0 or not. 1 is busy, it's being used. So until 0. If 0, then put the data, okay, and so on. Later it's a change in the busy bit, it's because that the device is used, okay, then do it. Problem? Because you need to keep checking such a device, it's called the busy bit. So we have discussed about this one. To address such a busy way, we can do the interrupt based. So we can use the interrupt. So interrupt based, so raise your signal, send the signal, then stop all the operation, then do the I/O operation. That is the interrupt based. Okay. So this slide shows that this is your computer, CPU mostly. This is your I/O controller. If you, as I suggested, you can regard the computer versus computer, like the processor versus processor. So you can just send the signal, the interrupt, then it will start, then initiate the I/O, then the change the status bit, and you can use such a data in register, data out register, and so on. Then send back to the CPU such a data. If this is the hard disk drive, the data retrieved from the hard disk drive will be returned to the specific memory area. Then the CPU can read the data from the memory. That is managed by the such an event, such an interrupt event is managed by the vector, which is called the event vector table. In case of 0, that is the divided by 0. You already know this is the most significant error, so we will take care of the, as we discussed, divide by 0 is the 0, 1. And then the other interrupt signal will be defined as a vector. And the vector has some operation, okay? So operation, so you can do something action for that. So that is defined by the CPU, not your operating system. So each CPU has such a defined number of the event, which means the interrupt vector. Then there's the action to do something, the kind of event and action. And also another type of the think about I'd like to read 1 byte of data. What happened? You can send the block ID, logical block number, the file name, or whatever is a high level, the logical name, address of the data. Then this controller will convert the request by the sector number, cylinder number, disk number, then read the block, 1 block, and return 1 block to the memory. Then the CPU can read the data. What about the next block? You need to do the same thing. And when you read the 1 megabyte, the file size, how many times you need to do? At least 20, 200. So 1 megabyte divided by 512 bytes. Okay, that will be 2,000. 20, yeah, 20, 24, 24, 48. So 2K times you need to do that. It's the overhead. Every time it will be stop the interrupt and read the 1 byte, 1 block, and 1 block. So